if the object is falling at terminal velocity, its acceleration is 0. So the forces must be balanced. The forces are in equilibrium. Right? Forces are in equilibrium. So let's see which statement is invalid. Actually, it's C. Right? If you go through the other three, it says the acceleration of the object is 0. That's correct. Right? There's a resistive force acting on the object. Of course, yes. There must be a resistive force to balance the weight. Otherwise, the object won't reach the terminal velocity. Right? Resistive force acts upwards, weight acts downwards. So they balance each other so that resultant force becomes 0, acceleration becomes 0. There is a resultant force acting on the object. Cannot be the case. If there's a resultant force acting on the object should be accelerated, but the acceleration is 0 here. So C is the wrong answer. The object has a weight, obviously. Object must have, otherwise it won't fall. Right? Question number 2. Right. I think you guys have read the whole scenario. And they have said that the force from the rod to the pump can be neglected. And the only two forces which we can consider in this case would be the weight of the beam and the tension of the steam cylinder rod. So we need to find tension. They have given us distances and the weight of the beam, right? Whenever we need to connect distance and forces, right, most of the time it's moments, right? So we got to use principle of moments. Consider the balance of the moments so that you can find C. Yeah. So when you use principle of moments, clockwise moment should be equal to the anti-clockwise moment when the moments are balanced. Right. So it's not a difficult question, but you need to read carefully to find whether, understand whether the beam is uniform. If the beam is uniform, the weight should act from the center, or rather the midpoint of the beam. That's 3.05 into 10 to the power 4 kilograms. So it's 3.05 into 10 to the power 4 G. So there are two forces acting on the beam. One is its weight, and the other one is steam cylinder, the tension of the steam cylinder rod, or that force, T. Those are the two forces. The point P is considered as the pivot in this case, right? So this force is 0 here, right? This force is 0. So these two forces produce moments about P, because the beam can rotate about P, right? Weight produces a clockwise moment. T produces an anti-clockwise moment. Let's see how we can find the distances from pivot to T. Right. So let's draw the line of action of T. This is the line of action of T. And now let's draw a normal from P to line of action. Because we need to take the perpendicular distance from pivot to the line of action of the force. right? Since this angle is 20, this angle is 20 as well. The distance from this N to P is 6 meters, right? This distance is 6 meters, right? So when you consider the triangle that I have marked here, hypotenuse is 6 meters. The angle here is 20, that red one. So the length of the normal is 6 cos 20 because that side is, the side is adjacent to the angle, right? So this side is 6 cos 20. 6 cos 20. Yeah. So the moment due to tension is T times 6 cos 20. And then we need to find the moment of weight of the beam. Weight is 3.05 into 10 to the power 5 into 9.81. That's just mg. Then the distance, perpendicular distance from P to line of action of weight needs to be found, right? So it's going to be a cos 20 value as well, because if this horizontal distance is cos 20, this also should be cos 20. But the thing is, what is this little distance? Right? Got to find that. This is a uniform beam. Its total length is 11.5. Right? 11.5. So the weight acts exactly at the middle of the beam. So it should be at 5.5 meters from one of the corners, right? And then the distance from P to corner is 6. Distance from corner to center of gravity is 5.5, right? So then the distance between P and center of gravity should be 0.5. 0.5 meters, right? 0.5. P is here. Center of gravity is here. Distance to P from the corner is 6 meters. Distance to center of gravity from the corner is 5.5, right? So then distance from P to center of gravity would be 6 minus 5.5, 0.5 meters, right? So the perpendicular distance from P to line of action of weight would be 0.5 cos 20. Then accordingly, you can find T. T should be 24.9.
Shouldn't it be 10 to the power 4? In the calculation, it's 3.04 into 10 to the power 5.
Yeah. Should be 10 to the power 4.
So how come it gives 24.9? It's 10 to the power 4 and you divide by 6 because the cos 20 cancels out. So
Yeah.
it should be 0.5 into 3.05 into 10 to the power 4 into 9.8 and divided by 6. So the value has to be way larger than this.
Yeah, what's the value you got?
24,900.
4,900. What about the others? What are you guys getting?
Yes, I get the same answer. 24,000. Yeah, same answer as you said. It's not the
Yeah, it must be the case. 24,900. Yeah,
Yes, sir.
right. 24,900 newtons. That's the answer. All right, so it's 24,900. Okay, fine. Question number 3. So next part of this question, part B. Right, so the engine which can continuously would lift a mass of 2,500 of water through 12 meters each minute. The water is lifted to a height of 12 meters each minute. The engine used 1,250 kilograms of coal a day. 1 kilogram of coal can release 22.3 megajoules of energy. The beam engine was said to have the efficiency of 10. Deduce whether this claim for efficiency was correct. Okay, so 2,500 kilograms of coal is lifted 12 meters each minute. This is the useful work done. And this useful work done is given per minute. And the input energy is produced by coal. Each 1 kilogram of coal produces 22.3 megajoules. And in a given day, you use 1,250 kilograms of coal, right? Accordingly, you should be able to find the total input energy, right? Now, since we are supposed to find the efficiency, we use the efficiency equation. Efficiency is equal to useful output energy divided by total input energy into 100%. In this case, there are some conversions to be done because we need to bring the amount of energy to energy per same time, same duration. Because the amount of energy used depends on the time that you spent, right? The time that you, the amount of energy that you spent per minute, per second, per hour, a day would vary, right? So energy, useful energy is given per minute. Energy input is given per kilogram and per a day, right? Okay. So first we'll start with the equation. Now, what is the useful energy? The useful energy in this case is decided, any case, it is decided based on the output. We decide the useful energy based on the purpose. Our purpose is to lift water to a height of 12 meters. That's the useful energy. So when you lift it, you provide a gravitational potential energy is given to the water, right? So that is the useful energy. So the useful energy would be the gravitational potential energy gained by water. So that can be found by mgh, gravitational potential energy, and that can be found using mgh. So the mass of the water is 2500, G is 9.81, Hg is 12. Then this is per minute. If you want to find out the amount of energy per day, you need to multiply this energy by the amount of minutes, the number of minutes per day. Right? So the energy needs to be multiplied by number of minutes. So how to find the minutes per day? 24 into 60. 24 into 60. And then you divide that by total energy consumption. Right? What is the amount of coal consumption? 1250. 1250 kilograms. And we produce 22.3 megajoules of energy per kilogram. So the total amount of energy produced would be 1250 kilograms into 22.3 megajoules per kilogram. Right. Now do the calculation and see whether you're getting an answer close to 10 or not. We got to justify whether the efficiency is 10.
It's less than 10.
Yep.
I found it less than 10.
Less than 10. Yeah. What do you get, Mishindi?
I got 1.52.
1.5%. Right. So less than 10%. So the statement is incorrect. Right. Question number 3. A physics class made a toy rock. A drinks bottle was partially filled with water and inverted over a valve. An air pump delivered air to the bottle until the pressure forced the bottle from the valve and the water was ejected from the bottle at high speed. A velocity time graph for the bottle for the first 4 seconds after takeoff is shown. Determine the height of the rocket travels. Right. So at the launch of the rocket, it picks up its velocity very fast. Right? It's an impulse. It's a sudden force. given to the rocket in a small amount of time, so its velocity is greater. So in this velocity time graph, during the first part of the graph, the velocity picks from 0. It is picked up from 0 to 20. 0 to 20 within a small amount of time. So it's just a 1 square here. So what's the value of a 1 square? So the 5 squares is equal to 1 second. So 1 square is equal to 1 second divided by 5, which is 0.2. Right? So during the first 0.2 seconds, the velocity becomes 20 meters per second. Determine the height which the rocket traveled. Area under the velocity time graph gives the displacement, right? So where is the maximum height? At the maximum height, the velocity is 0. Right? When the rocket comes to the comes to the maximum height, the velocity is 0. Yeah. Velocity becomes 0 here. So this is the maximum height. That's the maximum height. So that will be the area under the graph. If you take the whole area under the graph, which is the initial part of the graph, it will be a triangle. So it will be half into base 1.9 into height 20, roughly about 19 meters. Right, sketch the corresponding acceleration time graph for the axis below. The other feature of velocity time graph is the acceleration. The acceleration is given by the gradient of the graph. In the first part of the graph, there is a huge acceleration to bring the velocity to 20 in 0.2 seconds. So we can find the initial acceleration using the gradient of the graph. So that will be 20 divided by 0.2 seconds. That's 100 meters per second squared. Then it decelerates in the second part. In this part, it decelerates. So that can be found from the gradient of this part of the graph. Height is again 20. The time taken would be, it's 1.9 here, and it's 0.2 here. So the difference of 1.9 and 0.2 would be 1.7. So the run is 1.7. Price is 20. So 20 divided by 1.7. 11.8. So it's approximately 12 meters per second squared. And that continues for a while, and then gradually it decreases, right? Slope decreases. So then acceleration decreases. After about 2.5, about 2.5 seconds, acceleration decreases. Right, now we have information to draw the graph. During 0 to during the first 0.2 seconds, acceleration is 100. Then 0.2 to 1.9, it's a deceleration. So negative acceleration, about 12. And it continues until about 2.5. And the acceleration then decreases because the slope decreases. Right. So your graph should look like this. Initially, the acceleration is 100 positive. Then it's about 12. And it continues for like 2.5 and then gradually it's decreasing until 4. So you need to draw the graph until 4 seconds. If this graph is drawn up to 4 seconds. Okay, then moving on to question number 4. Moment is force into perpendicular distance. Force is W. Perpendicular distance from the pivot will be d cos theta. D, this distance, d cos theta. So W d cos theta. Answer is B. Fifth one, a space rocket lifts off vertically. The rocket lifts off because the exhaust gases exerts a force on the rocket. Rocket exerts a force on the gas. According to Newton's third law, gas exerts equal and opposite force on the rocket in the upward direction. So that's why rocket moves. So C and D are anyway not correct because the ground does not exert any force on the rocket. The rocket does not push the ground to go up. Rocket goes up by emitting gases. Right. Question number 6. A track for toy car can be built with circular loop as shown. A toy car is placed on the track at various heights. It travels around the loop before leaving the track horizontally at X. The toy car just completes a loop without losing contact with the track. Show that the speed of the toy car at the bottom of the loop is about 3 meters per second. R is 0.15. In this case, we need an extra knowledge. I'm going to give you that. So you can use it. Right? If the car completes the loop, the velocity at the top the square value of the velocity at the top would be equal to RG. Right? Use that information to do the question. Right? So velocity at the top is equal to RG. What is R? Radius of the loop. G is gravitational phase strength. Right? We can prove this using the knowledge of circular motion. Right? Right. But anyway, rest of the question is around energy. Right? It's all about the energy. Rest of the question is all about the energy. If you assume that there is no energy loss when car moves along the track and the loop, its gravitational potential energy is converted to kinetic energy, and the kinetic energy is converted to gravitational potential energy. Right? So if you consider the motion inside the loop, and gravitational potential energy is 0 at the level of the table, at the top of the loop, the car will have both kinetic energy and gravitational potential energy, right? So the total energy at the top of the loop would be the addition of kinetic energy plus gravitational potential energy both. And then car moves down to the level of the table. So when the car comes to the level of the table, gravitational potential energy becomes 0 because we define GB is 0 at the level of the table, right? And the kinetic energy is there because it's moving. So you can write this equation, right? Total energy at the top is equal to total energy at the bottom. That is law of conservation of energy. The kinetic energy at the top plus GP at the top is equal to kinetic energy at the bottom plus kinetic energy, GP at the bottom. So kinetic energy at the top is half m v top squared plus mg, h is in this case 2r. Height is equal to 2r. R is the radius. Yeah. Then at the bottom, kinetic energy is half mv m bottom squared plus gp is 0, right? So m is common, so m can be cancelled out. And the v top squared is equal to rg. Now you should actually have it. I mean, you should be able to derive it, but since we can't do it, I'm giving it to you. It should be rg, right? So v top squared is rg. So we substitute that value here. V top squared is rg. Right? If you have v top and v bottom both in the equation, there are two unknowns in the equation, right? So we need to get rid of one of the unknowns because we need to find v at the bottom. Right? We need to find the velocity at the bottom. So then v top squared over v top squared is rg over 2gr, right? R is given, it's fine, g is known. So now we're able to find v from this equation because r is given and g is known to us, right? So then you rearrange the equation, subject v, and then substitute values and get the answer, right? So finally v becomes square root 5rg. What are we getting, guys? See 2.71.
Yes, sir. It's 2.71.
Okay, 2.7. Let's move to question number 7. A student carried out an experiment with coins. She gave 2 pence coin a sharp tap so that it slid along a horizontal surface and came to rest as shown. Initial velocity of the coin is u, and at the final position, as in when it comes to rest, it has displays s. The student recorded the distance s moved by the coin. So then she then replaced 2p coin with 1p coin and repeated the process. Right. Now 2p is replaced by 1p and repeated the process. The student read that the frictional force between object and surface is directly proportional to mass of an object. Right. Friction is directly proportional to mass. Directly proportional to mass. She suggested that in her experiment, u is directly proportional to square root s and is independent of mass of the coin. Right. When you're supposed to show this kind of relationship, so we need to show that u is directly proportional to s. And when you're supposed to show a relationship, you can make an equation. And in that equation, u must be directly proportional to square root s, as well as there should be m in that equation, because u is independent of m, mass. Right? So basically, you need to mathematically prove it. So we need to come up with an equation. So when you want to come up with an equation, linking certain quantities, according to the application, you need to figure out what are the equations you can use, or what is the equation you can use. They have given us initial velocity, final velocity, displacement. So it looks like we can go from motion equations. There are some other methods also, right? So we can go for a motion equation. Since there is no involvement of time, there is involvement of velocities and displacement. We can go for v squared equals u squared plus 2as equation. Final velocity is 0, initial velocity is u. Acceleration is unknown, right? That's a bit of a problem. There is one unknown in the equation. And s is also given, right? Rest are fine. So 0 is equal to u squared plus 2as. And u squared is equal to minus 2s. Right? Displacement and acceleration are vectors. Right? So u is equal to square root minus 2as. The value inside the square root cannot be minus if it is a real number. Right? So then one of these should be negative. Of course, acceleration has to be negative because displacement is measured from the initial position. So it is measured this way to the right. That is positive. Acceleration, since acceleration is opposite to that, because it's a deceleration, it's negative. That's why there's a negative sign. So you can actually omit that if you want. Right. Now the thing is, what you want to find out is the relationship between u and s. But then there is acceleration. Now we have got to get rid of acceleration, or need to prove that the acceleration is constant. And the acceleration is f is equal to ma. So the acceleration can be linked with the force. What's the force that we're talking about? The frictional force. Frictional force is the one which causes this deceleration, right? Frictional force causes the deceleration. Yeah. And according to the context, the data or the information got from a book, the child says friction is directly proportional to the mass, right? So I wrote it here. Friction is directly proportional to the mass. So that means friction is equal to a constant times mass. And at the same time, that force is equal to ma. F equals ma. Because resultant force, frictional force is the resultant force here. So that is equal to ma, right? If we write this separately, according to Child's statement, F is equal to K, M. And at the same time, F is equal to M, right? Now you can equate through, right? Km equals to Ma, right? When you cancel out M, acceleration is equal to K. Right? Is K is a constant. So that means the acceleration is a constant, right? Now we are sorted. If the acceleration is constant, U is directly proportional to S. So the statement is correct. Should I move on or should I hold on? Dinesh, we have proved that the acceleration is constant based on that statement. Friction is directly proportional to mass. And you can use kinetic energy equals to work done against the friction as well to do this question. That's the second method. Thumbs up if you are done. Okay. Question number 8. Two gliders X and Y are placed on an air track. The gliders are pushed towards each other. The gliders, if it is an air track, no friction. Right? If there is no friction, there is no external force. If there is no external force, momentum before collision must be equal to momentum after collision. So, law of conservation of momentum, right? So, what's the momentum before collision? That is 0, right? Where the momentum of x is 0.5 times its mass times velocity, 0.5 times 2. That acts towards right. Okay, 0.5 times 2. It acts towards right. And the momentum of y, its mass 1 kilograms into its velocity 1. 1 into 1 is 1. That acts towards left, right? So 0.5 into 2 is 1. The momentum of x is 1 towards right. Momentum of y is 1 towards left. Right? They are equal and opposite vectors. They cancel each other. So the total momentum before collision is 0. Total momentum before collision is 0. If the total momentum is 0 before collision, total momentum must be 0 after collision as well. Total momentum must be 0 after collision as well. Right. So what are the possible answers? Let's take B. Both are minus. Right? Both velocities are minus. If both velocities are minus, when you add them, when you multiply the masses with velocities, momenta also will be minus. If the momenta are minus, the total momentum also will be minus, right? Minus won't be cancelling each other. And same with C as well, right? So C and B are anyway wrong. And when you take D, that can't be the case. One is positive, one is negative, but the velocities are same. Velocities cannot be same because the masses are different. When the masses are different, velocities cannot be same because initial momentum was 0. Right? So obviously the answer is going to be A. Right? You can do this exercise to find out the right answer. Or you can do a little calculation. Starting from first one, if you do it, you'll get the answer from the first one itself. The first choice A gives you the answer. Because when you multiply -1 by 0.5, you get -1 by 0.5. Right? I'm taking A. Minus 0.5. You need to add the momentum of y, and this is momentum of x. The momentum of y would be mass of y 1 into plus 0.5, right? So that's plus 0.5. So minus 0.5 plus 0.5 is 0 again. So that's correct. So the momentum is conserved. Before collision it was 0. After collision, it must be 0, right? So these two velocities will give you 0 momentum after collision. Question number 9. A uniform paving slab is to be used as a garden step. State what is meant by the center of gravity. The point through which the weight acts. That's the center of gravity. The point through which the weight acts. Part B. The paving slab has a weight of 310 and it's a uniform. If it is uniform, weight of the slab should act through the center, the midpoint of the slab at the midpoint. That is 45 centimeters from one end. 45 centimeters from one end. So I have marked 310 and the length from one of the ends to the center of gravity. That is 45 centimeters, half of 90. And will support at 2 points, P and Q. The distance between P and Q is 75. This might be unsafe because a person who places all their weight at the end of the slab might tip the slab. The person of mass 70 kilograms stands at the end of the slab. Deduce whether the slab will tip. Right? To determine whether the slab will tip, you can use you can find the moments about P. If it's going to tip, it's going to rotate about P, right? So we can find the moments about P, right? If the moments are unbalanced, as in if the moment produced by the person is greater than the moment produced by the weight, this will rotate, the slab will rotate anti-clockwise. So it will move out from Q. Right? So the person produces anti-clockwise moment. If he produces an anti-clockwise moment greater than the clockwise moment produced by the weight, the slab will tip. So we can find the moment of the weight of the person about P. Right? About P. So we need the distances. The weight of the person is 70 G, 70 into 9.81. The distance is 15 centimeters, right? Because the distance from Q to center of gravity is 45. Distance between P and Q is 75. So P to center of gravity is 30, right? And this N to center of gravity is 45. So the distance from P to 70 G would be 45 minus 30. 45 minus 30 is 15 centimeters. 15 centimeters. So 17 to 9.81 into 0.15. 0.15 is the distance. So that's 103 Newton meters. And you can find the moment about the slab of 310 Newton. The weight of the slab. Moment of weight of the slab is 310 into distance to 310 from P. That's 30 centimeters. That is 0.30 meters. So that becomes a lower value. So that's lower than 103. So that means moments are unbalanced. So the slab will tip as the anti-clockwise moment is greater than the clockwise moment about P. Right. Question 10. Scientists have been studying a type of jumping spider that can jump up to 6 times its body length. Just as the spider starts to jump, it fixes a silk thread to the platform. It is thought that the thread acts as a safety line in case the spider falls. The student makes the comment, if the silk thread can withstand tension equal to the weight of the spider, then this safety system could work, right? So the statement is simply the tension, if the tension is equal to the weight, the safety system works, right? But now we'll analyze this using physics knowledge. When the spider, if the spider is hanging with the silk thread, and if the spider needs to come to rest, the spider should decelerate. The spider decelerates simply if the tension is greater than the weight only. If you draw a diagram, you can identify, right? Because weight acts vertically downwards. If the tension is greater, spider will be decelerated because the spider is going down, right? Spider is moving down, right? So the tension acts opposite to the motion, right? The spider goes down because of the weight, downward force. That if there is a opposite force which acts against the weight, which is greater than the weight, then the spider will decelerate. So obviously tension has to be bigger than the weight. But then we can prove it also, right? You can write a statement, 2 points, because the spider has to decelerate. So to decelerate, tension has to be greater than the weight. So 2 points. But at the same time, we can use an equation, maths, to prove this. When the spider goes down, if you use F equals ma to the spider in the downward direction, you'll get W minus T equals to M into A. In this case, the acceleration is opposite, so it's negative A, right? So then the tension would be, when you subject tension of this equation, tension equals to W plus Ma, right? W plus Ma. So the tension is greater than the W because Ma is a number. When you add this value to W, tension will become greater than W. So tension will be greater than W. So then the statement is wrong, right? If the tension is equal to W, there will be no acceleration, but no deceleration. So it won't come to stop. Right? So decelerate, it has to be greater than the weight. Tension has to be greater than the weight. Question number 11. A ball was dropped from a rest, so initial velocity is 0, from a height above the ground. The ball bounced back up to about half of the initial height, which is the correct graph. A is the correct graph. Right? It's dropped at 0, so initial velocity must be 0. So all graphs have initial velocity 0. right? And then its velocity increases. So A, B, C, D all are correct because velocity increases from 0. That's fine. But after it hits the ground, it bounces back, so the velocity changes the direction, right? So let's take A, right? At this point, ball hits the ground, and then it bounces. When it bounces here, right? When it bounces, velocity changes, right? So if the velocity of the ball when it hits the ground is positive, as it bounces, the velocity must be negative, right? Right. So velocity becomes 0 again at the maximum height. So this is the maximum height. A and B both have the same shape. So D and C are out anyway. A and B both have the same shape, right? But it's more likely to be A because the area after bounce is very small. If you take B, it doesn't look like half. It's like 1/3. So that's why B is wrong, right? So A seems to be the closest answer, not B. And this part of the graph, area under the graph gives the height. Question 12. The World Solar Challenge is set every 2 years in Australia. The challenge is to complete a 3,000-kilometer route with vehicle powered only by sun. The vehicles have their surface fitted with solar panels as shown in the photograph. The vehicle can reach maximum speed of 34 meters on flat ground. Electric motor used to move the vehicle has a power of 4.5. Calculate the initial acceleration of the vehicle as it starts from rest. Right. To find the initial acceleration, we need the force. To find the acceleration, we need force, resultant force. How can you find force from power? So most of the time we get the scenario where power is linked with the force and the velocity. Power is work done over time. Work is force into displacement divided by time. Right? If you separate displacement over time, that's velocity. Right? So the power is equal to force times velocity. Power is 4.5 kilowatts, that is 4,500 watts. Force needs to be found, be the average force, right? Can vary. Velocity is 34. So the force is 4,500 divided by 34, 132. Right? Now we have the force. You can use F equals ma to find the acceleration. Force is 132 equals to mass 420 into acceleration 0.31 meters per second squared. And then they ask an assumption. So we have assumed that the frictional forces are neglected.
So I have a question. Would the acceleration be 0 once the vehicle has reached maximum velocity?
Yeah, when it reaches after it reaches the maximum velocity, the acceleration will become 0.
So how can you assume there's an acceleration when
it has to be accelerated? No. Initially, it has to be accelerated. Otherwise, how can you reach that speed? Can you reach a speed without acceleration? Can you? No, you can't. right? So it could be a small time even, right? Even if you think of, let's say, an impulse, right? Like in momentum, we do that, right? So in momentum, acceleration or deceleration is caused by a very large force in a small amount of time, right? But still there is acceleration or deceleration. Right, let's move to the next set of questions. In the sport of curling, two teams of curlers take turns sliding polished granite stones across an ice surface towards a circular target marked on the ice. A stone of mass 19.6 kilograms is accelerated uniformly for 1.25 seconds. Right, a stone of mass 19.6 kilograms, right, is accelerated uniformly for 1 to 5 seconds. So 0 to whatever the speed, let's say u, within 1.25 seconds, right? So it's accelerated to a certain speed within 1.25 before being released by the curler, right? So you are pushing it until you get the speed and then you release it out. And the stone then decelerates uniformly to rest. And you released, the curler released it. So it decelerates to rest. Traveling 32.5 meters in a time of 17.5 seconds. Right? Then what's the next scenario? There are two cases here. In the first case, it accelerates from 0 meters and we don't know the final velocity, but the time is 1.25. The time duration is 1.25. Then it decelerates. So that is, again, it comes to 0 velocity after traveling a distance of 32.5 in a time of 17.5 seconds. Right. So deceleration takes place for 17.5 seconds. Right. So now understand the scenario. Initially, it is accelerated from 0 to u, unknown velocity, within 1.25 seconds. And then it decelerates for 17.5 seconds. And it travels 32.5 before it comes to rest. So final velocity is 0. Calculate the average useful power developed by the curler when accelerated. Right. So the power is a work done divided by time. The work done on the curve, on the stone, is converted to the kinetic energy so that it gains kinetic energy to move. Right. So the work done would be the change of kinetic energy. Change in kinetic energy. Right. Initially, it was at rest. So the change in kinetic energy would be the kinetic energy gained by it at the end. So that will be half mu squared. As per this, it's u divided by the time taken. Now you need to find u, right? Mass is there. You need to find u to find the power, right? A simple question, but mathematically you need to link few different cases like power, energy, and motion must be linked. Right. How can you find the U? Right. If you consider the first scenario, you have less information, you can't find. So then you got to consider the last bit, which is the deceleration. So they've given us displacement 32.5. Final velocity is 0. Initial velocity is unknown. Divided by d, the time is also given 17.5. So we use S equals U plus V over 2 times T. S equals U plus V over 2 times T. Right? S is 12.5. U is U. UV is 0. Time is 17.5. So U is 3.71. U is 3.71. Right? Now you can use 3.71 to find the kinetic energy. So the kinetic energy change would be the kinetic energy gained actually half mv squared. And the time taken to gain this kinetic energy is the initial bit 1.25. So that's where 1.25 comes, not for the motion bit. So this was done. We can skip that. Question number 3. Sports class is studying cycling. They produce a video of a cyclist on a horizontal lawn. The cyclist starts from rest. They produce a sketch graph of velocity v of the cyclist against the time. Explain the shape of the graph and include consideration of force as a part of your answer. We know gradient of velocity time graph is the acceleration. Gradient decreases gradually, so the acceleration decreases. Finally, gradient becomes 0. So the acceleration finally becomes 0. And also, we know acceleration depends on the resultant force, F equals mv, right? If acceleration reduces, resultant force must be reducing. If acceleration is 0, resultant force must be 0. So at this, eventually, acceleration is 0, resultant force is 0. Why? Forces are balanced. So what are the forces? The forward force, the frictional force must be balanced. So since you are supposed to consider forces in your answer to explain the shape, you need to talk about the forces. So initially there's an acceleration. So there is a resultant force. Acceleration decreases gradually as the drag force increases. Finally, forces are balanced, so the acceleration becomes 0. Part B, the student makes the following statement. The work done by the cyclist is converted into kinetic energy of the cyclist and bicycle. Criticize this statement. As per the graph, we already discussed about drag force, right? If there is drag force, it opposes the motion. So if it opposes the motion, the cyclist has to do some work against the drag force. So some work is utilized to overcome the drag force anyway, right? So the work is done against the drag force, or the frictional forces. So some energy is lost or utilized to do work against the resistive forces. When finally speed becomes constant, the kinetic energy would be constant as well. So there is no increase of kinetic energy once the forces are balanced. So obviously that statement is wrong. Because the work done by the cyclists won't be anymore converted to kinetic energy when the speed is constant. So at that point onwards, the energy will be converted to other forms of energy. Because the drag force is greatest now. So the energy is lost as heat energy or sound energy. So the statement is not right. Right, question 12. The shot put is an Olympic field event. The distance for the women's world record shot put is in excess of 22 meters. The shot is metal ball. It's a metal ball which is thrown from a standing position so that it lands on the ground horizontally, a distance r away from the thrower. The shot is thrown from a height of h above the ground with an initial velocity 14.2 at an angle of 37 to the horizontal. The time it takes for the shot to reach the ground is 1.98, right? So the initial time is taken as 0. Initially, the time is taken as 0. The time taken to reach the ground is 1.98. Show that the vertical component of the initial velocity is 8.6. So the vertical component is 14.2 sine 37. 8.546 is close to 8.6, 8.55. Calculate the height above the ground from which the shot was thrown. So basically, you need to find the displacement. You know the vertical height. Vertical component of the initial velocity. We found it, 8.55. We know the time taken for it to reach the ground, 1.98. We know the acceleration is 9.81, right? So we can use S equals ut plus half at square. So h is equal to ut initial velocity, initial vertical component of the initial velocity. Vertical component of the initial velocity is 8.55. Time is 1.98 plus half into negative 9.81 because we are applying the equation upwards. 9.81. Acceleration is acting downwards. So it's negative 9.81 times t, 1.98 square. So h is equal to negative 2.3. Why it's negative? Because the distance is measured downwards when we apply equation upwards. Right? Distance is measured from the initial position. This position is the initial position. And it's measured downwards where upward direction is positive. When you measure it downwards, it's negative. Right. Calculate the horizontal distance R for this throw. Horizontally, you can use only you can use S equals UT. Horizontal distance is R. Horizontal velocity is 14.2 cos 37. Right. This is always constant. 14.2 cos 37 is always constant into 1.98. The total time taken. So it's 22.5. Right, this one was done. You can skip it. Right, question number 6. Okay, scientists have been studying type of jumping spider that can jump up to 6 times its body length. The scientists photograph a spider at 0.02 intervals during a jump. The picture is taken from a photograph and it's shown the actual size. So the length are actual sizes. Yeah. Deduce whether images show that the motion in the x direction is independent of the motion in the y direction. You should take measurements using the cross marking the center of gravity of the spider. So the cross marking is the center of gravity of the spider. Right. If you measure the horizontal distance between two consecutive photographs, images of the spider, it's same, right? So the direct distance is same between images in the x direction. If the distances are same, you know, the time between two images is same. That's 0.02. If the distance is same during a given time interval, velocity will be same as well. But in the upward direction, vertical direction, distance vary. Right? Initially, when you take first two images, vertical distance is higher compared to second and third. Second image is closer to the third one. And then when you consider third and fourth, the fourth one is below third one. And the fifth one is way below the fourth one. So that means vertical velocity varies with the time. Right? Vertical velocity varies, but horizontal velocity does not vary. So that means horizontal velocity is unaffected by the change of vertical velocity. Horizontal velocity is unaffected by change of vertical velocity. So that means motion in the y direction is independent, or motion in the x direction is independent of motion in the y direction. Right. Part 2. Show that the initial velocity of the spider at the start of the jump is about 1. As per the diagram, spider jumps at an angle, right? Because the motion of the spider follows a kind of parabolic path, right? So it's a projectile, angle projectile. That means the spider must have vertical and horizontal components at the beginning. Its velocity is at an angle. So we can go for vertical velocity and horizontal velocity separately. Try to think, how can we find the vertical component of the initial velocity and horizontal component of the initial velocity. If we find the vertical component and the horizontal component, we can use Pythagoras theorem to find the resultant velocity, right? We can do that by using the distances between images. Yeah, they have said that the distance is the actual distance, and the time can be found depending on the number of images. The time gap between two images would be 0.02. Right? So there are 1, 2, 3, 4 gaps. So the total time would be 0.02 into 4, 8.08 seconds. Right? The image 3 seems to be the maximum height. Right? Because the spider is the image before that image is below that image, and also the image after that image is below that image. So that seems to be the maximum height. Yeah. Assuming that's the maximum height, if you measure the maximum, if you measure the height for that image, actually you have to measure it up to the center of gravity of the spider, right? So you can consider that as the maximum height. At the maximum height, vertical component of the velocity is 0, right? So you know the maximum height, you need the acceleration, it's 9.81. So you can find the vertical component of the initial velocity using a motion equation there, right? So we can use v squared equals u squared plus 2s. So the maximum height has to be measured, right? You measure it, it's 0.011 meters, right? So at the maximum height, the velocity is 0. Initial velocity is the vertical component of the initial velocity. Plus 2 times acceleration is 9.81 into 0.011. So the value would be 0.465. Right. So what are the steps you need to follow? Measure maximum height. Measure maximum height. And then second step, we use v squared equals u squared plus 2s. And find the velocity. We found the vertical component now, vertical component of the initial velocity. Now you got to find the horizontal component of the initial velocity. Right? You can find that by considering the horizontal motion. Right? You can find the horizontal distance, measure it. Measure the horizontal distance from center of gravity of the first image to the center of gravity of the fifth image. So that's 0.08 meters. And to reach that point, it has taken 0.08 seconds, right? Because there are 1, 2, 3 gaps. 0.08. So it will be 1 meters per second. So the initial velocity is square root of these two square root of 0.465 squared plus 1 squared. 0.465 is the vertical component. 1 is horizontal component. So it comes to 1.1. The spider achieves this jump by extending its two back legs by 3 millimeters. Calculate the average force the spider exerts in each leg to achieve the jump. Here, the work done by the spider is converted to its kinetic energy so that it can jump. So it produces, it generates energy by doing work. How does it do work? It uses its back legs, two back legs. It extends them 3 millimeters to do that. Right? So the work done by the spider using its legs is equal to the kinetic energy gained by the spider. Since the forces are exerted by both legs, so the work done can be found by multiplying work done by one leg by 2. The work done by one leg is force times force exerted by a leg into the distance. Since it's 2 legs, that has to be multiplied by 2. Right? So that work done would be equal to kinetic energy gained by the spider. So that's half m mass into square, v square. Mass is 150 milligrams. So it's multiplied by 10 to the power minus 6 to convert that to kilograms into v squared. V's velocity is 1.1, which we found. So the force would be 0.01015 newtons.
Excuse me, sir. Sir, can't we consider the elastic strain energy when we consider the work done by the spider's legs, because they say the legs are extended?
Do we have information to consider elastic energy?
So could we take the extension as 3 millimeters for each leg? That's what I'm mentioning. So then half fx as a half f delta x, and then
Half f delta x squared. Is it?
oh yes, 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 for each leg. So then we can multiply that by 2 and equate it to kinetic energy. Is that? Um,
When you say average force, it's already included in it, right? Average force is, let's say, initial force is 0. And the final maximum value of the force is F. So average force is 0 plus F over 2, which is F average. That's F over 2.
Yeah.
So, isn't it? When you say average force, it's included. Yeah. Average force. Okay. Next one. We have been given different sizes of raindrops, their diameters and the terminal velocities. Derive using Stokes' law the following expression for terminal velocity V of a spherical raindrop in terms of R, where rho is the density of the rainwater and eta is the viscosity of air. Should ignore the upthrust. If you ignore upthrust, at the terminal velocity, drag is equal to weight. Drag is 6 pi eta RV. Weight is mg, and m is v rho. V is 4 over 3 pi r to the power 3 because it's a sphere. Volume of the sphere into density of the raindrop times t. So then you can rearrange that. When you rearrange the equation, we get this expression. As in the exam, you're going to get marks for the substitutions, your concepts, and you're not going to get marks for rearranging it because it's just 2 marks, right? So therefore, we should not spend much more time in doing this. Right. Show that the expression given in A produces a value of 8 for terminal velocity raindrop when rho is this and eta is the given value. So you can do this yourself. Just substitution. Right. Explain the Stokes' law is suitable for calculating the terminal velocity of raindrops. Stokes' law is valid if the raindrop is small, if the speed is lower, and flow is laminar. Right. In this experiment, about Hooke's law, we have been given the force and the extension as mass as well. Criticize the results. Table. Significant figures are different. And no repeats shown. Right. This is a very common repeated question in Unit 3 paper. And then we have drawn a graph of force versus the extension. Look at the graph. The line of best fit, which is the average line, is drawn in between the points, right? So there are 3 points at the top of the graph, and there are 3 points at the bottom of the graph, and the 4 points are closer to the graph as well, right? So in either side, there are 3 points each. So it's an average line. Determine the value for K. We know F equals Kx, K delta X. So K is equal to force divided by delta X. Force divided by delta X is the gradient of the graph. So K is equal to gradient. So we should find the gradient. When you're finding the gradient, you need to at least use more than 50% of the line. So the best would be use the biggest triangle possible. We can use the whole triangle in this case because it's easier. And that's pretty much all right. Can do it. Okay. So with that, we will wind up the class for the day. And tomorrow we'll be discussing some different questions. And meantime, I'll be sharing some notes and the previous revision papers and their answer scripts as well. Please go through them, do them, practice questions, and revise your theory with the questions. When you do questions, time and do them. Right. Okay, guys. So good luck for the rest of the exams. And I'll see you all tomorrow.
Thank you, sir. Thank you, sir.
Thank you, sir. Good night.
Guys,
Thank you, sir.
bye. You're welcome.